Hello, welcome to Code Chef Starters 163. We are solving problem nice array. So in this problem, we are given an array of length n and an integer k. And A is set to a nice array if there exists an array B of length n that satisfies the following condition. That is, for every I from 1 to n, Bi can be Ai divided by k. So we can take either floor or ceiling. So let us suppose that Bi is equal to 5 divided by 2. So their floor value will be 5 divided by 2, whatever the quotient is, that is 2. And ceiling is plus 1, that is 5 divided by 2 plus 1, so that will be 3. So Bi can be any one of those. Now, and the sum of all elements of B should be 0. And we need to tell that if that condition is there, then A is nice. So we need to tell whether A is nice or not. So we have to solve this problem for t test cases. We will begin n and k. In the following line, we'll have an array of n elements. So if we see these examples along with the constraints that we have to, so ai can be 10 to the power 9, n can be 10 to the power 5, and k can also be 10 to the power 9. We have to solve it in big of n, sorry. And let's see the examples. So the example says that 2 divided by 2, 1. 4 divided by 2 is 2. 2 divided by minus 2 is minus 1, and 2 divided by minus 4 is minus 2. So if we see that 1 plus 2 minus 1 minus 2, their sum is 0. For now, ignore NCTR and PCTR. I will tell that what this variable denotes, but as of now, the sum total is 0. Let's go to another example. We have 2, 3, and 2, 3 SK. We have 5 and minus 6. So 5 divided by 3. So if we take the floor, we can take 2. If we take the ceiling, I can take it 2. So I have both the conditions. So we'll see both the scenarios. And 3 divided by minus 6, we'll have minus 2. Okay. In this case, what is the optimal way is to take the ceiling, because 5 divided by 3, their ceiling will be 2, and minus 6 divided by 3 is minus 2, their sum is 0. So in this case, it is optimal to take ceiling. Okay. If we see the another problem, we have k as 1, so anything divided by k will be that number itself, so their sum will be 1, which is not equal to 0. So this is not a good array. So rest 2 were there, third one was not a nice array. In the other example, we have k as 2, so minus 1 divided by 2 will be 0, 2 divided by 2 will be 1. But we can take the ceiling of minus 1 divided by 2, that will be minus 1, and 2 divided by 2 will be 1. So their sum is 0 again, and that is yes answer. The idea that is coming to my mind is that, is there a way that I can maintain that if it is modulus by the k value, I will simply add it to my sum. But if it is not, what I can do is I can maintain some counters that will tell me that this is giving a negative effect on my sum, and this will give the positive effect. Let us suppose I have this one, 5 divided by 3. So I knew that if 5 divided by 3 is 1, if we take the floor value, so I will add 1 to my answer, because 1 will be there itself. So I will add 1 to it, but I will maintain a counter of positive addition that I can make it plus 1 also. So for that, I have made this PCTR, that is positive counter. Similarly, I will maintain a negative counter, that is NCTR. And this will be for this minus 1 divided by 2. So I know since my minus 1 is less than 0, and if I take the ceiling of it, it will give me the element, what we say, no, minus 1 negative, we have to take the floor value, so it will give me the negative increment, so minus 1, because I can make minus 1 divided by 2, it will add to my sum as 0, but I can make it minus 1. So in that case, I will add it to my negative counter. So these are the two scenarios that I'm taking in case. So if we iterate this first example does not have anything related to counter. Let's see second example. So as I explained, I'm maintaining a positive counter, so divided by 2, there's I will store in some uh, 5 divided by 3, I did 1 to my answer. Minus 6 divided by 3, I did minus 2 to my answer. But when I was dividing 5 by 3, I added PCTR, incremented it by 1. And when I'm seeing the sum, that will be minus 1. And I will check that if I add PCTR to it, it is greater than equal to 0. So it can be that my PCTR is 5, but I only need 1. In the rest of the scenarios, I will use the base case. So I can add it. So it should be greater than equal to 0. If that's the case, I can make it so array A is nice, otherwise it is not. Similarly, if we go see the last example here, negative counter is incrementing. So I'm making it negative. Why so? Because what I'll do is finally I will check that 1 plus NCTR, is it greater than, in this case, less than equal to 0, because negative NCTR will have negative impact. So is this less than equal to 0 or not? And if I am adding PCTR, it is greater than equal to 0 or not, because we need the required number. If it is greater, I don't care, I will use the floor over there and I will add it. Otherwise I will utilize the ceiling wherever required. So that is all we have to do. So this is the code for that. First, taking NNK as input, maintaining an array A, taking the input, maintaining PCTR and NCTR and sum, iterating through the array A, taking the modulus k, that if I modulus k is not equal to 0, I will check that if I is negative, NCTR is reduced by 1, otherwise in PCTR will increase by 1, and sum I will add I by k. I will check that if sum is equal to 0, simply return yes. If sum is less than 0, then if adding PCTR, can it be greater than equal to 0? If that's the case, yes. Other case, if sum is greater than 0 and sum plus NCTR is making it less than equal to 0, then in that case also else. Rest in all the cases it will be no. So that is all we have to do in this problem, and that's all. If you have any query, do comment it out. If you like the video, hit the like button and do subscribe for more daily content. Thank you.